Hey guys, welcome back to lecture series on numerical methods for differential solution of a differential equation. So I already uploaded plenty of the videos guys in our channel. So if you are interested to see similar videos, go check here in I button or you will get all my playlist in our description box. Okay. Yes, so guys, in our today's video I'm gonna explain to you all one of the very much important method, okay, Kutta method, example based on the Kutta method. Okay, so without further ado, let's get down into our today's lecture guys. I'm gonna explain to you all one of the very much important example that mostly repeated in your SPPU previous year question paper, which is June 22, 17 and 21 for 5 marks. Okay, and last year it is also the similar question was there. Okay, so these are the question very much important guys. You just have to refer this example for your ENDSEM practice. Okay, so without further ado, let's get dive into our today's lecture guys. I'm gonna explain to you all first of all the example and then we go for the solution. Okay, so in our example we have to use the Kutta method, okay, of a fourth order to solve, okay, to solve this differential equation dy by dx which is equal to xy, y of 1 which is equal to 2 given, x is a 1.2 and h is a 0.2 it is given. Okay, all this data we have given over here. Okay, yes, now let's write down first of all what we have given, okay, inside solution. So dy by dx which is equal to xy, we know that dy by dx we write it as the f of xy. Okay, dy by dx as the f of xy. This implies dy by dx which is equal to xy. Okay, so this implies we got the f of xy which is equal to xy. Okay, so y of 1 which is equal to 2, again y of 1 which is equal to 2 given. Okay, this one is our initial boundary condition, so we write y of x naught which is equal to y naught. Okay, x naught, this implies x naught which is equal to 1, y of x naught which is equal to y naught, x naught 1 and y naught 2, y naught which is equal to 2. Okay, yes, after that x is a 1.2, we have first iteration need to start from x is 1.2 and h is a 0.2. Okay, so we have h is the 0.2, h is equal to 0.2. This is the all required data guys that we have here in our example. Okay, so let me write the Kutta method for fourth order. Okay, Kutta method for fourth order, it says that y1 which is equal to y naught plus y1 which is equal to y naught plus 1 by 6 k1 plus 2 times k2 plus 2 times k3 plus k4. Okay, bracket complete. y1 is equal to k1 plus 2 k2 plus 2 k3 plus k4, bracket complete. Okay, yes, now see that we need to replace all these values over here. Okay, y naught, k1, k2, k3, k4, everything here in our y1. Okay, so you will get the value for y1. So for this we need to know k1, k2, k3 and k4. Okay, let me define the value for k1. Okay, so k1 we know that k1 we write k1 which is equal to h into f of x naught comma y naught, h into f of x naught y naught. Okay, so h we have given already, h we have given approximation value as a 0.2. Okay, so f of xy is x into y, x naught y naught also given. Okay, so f of xy comma y which is equal to x multiplied by y, and x naught y naught, that means f of 1 comma 2 we write 1 multiplied by 2 which is a 2. Okay, so I got the value for f of xy as a f of x naught y naught as a 2. Okay, so what is the h we have here? See that guys, h into f of x naught y naught. Okay, so h it is already 0.2, f of x naught y naught it is a 2, replace all this value, you will get the k1 as a 0.4. Okay, so I got the value for k1. Okay, similarly we want the value for k2. What is the value for k2? K2 we write h f of x naught plus h by 2. Okay, x naught plus h by 2 and y naught plus this k1. Okay, this k1 by 2, k1 divided by 2. Okay, and this one is our value for k2 here. Okay, yes, now what we do, we replace all these values here. H is already there at 0.2, replace the value for h as a 0.2 under bracket f of x naught plus h by 2. Okay, what is the x naught? X naught we have here 1 plus 0.2 by 2. Okay, 1 plus 0.2 divided by 2. Okay, that means it is 0.1, comma y naught. What we have? Y naught 2 plus k1 0.4 by 2, 0.4 divided by 2. Okay, this is the bracket complete. So f of x comma y, we write x multiplied by y, so we are going to write 0.2 multiplied by under bracket 1 plus 1.1. okay, that means 1.1 it is there. Okay, 1 plus 0.2 by 2, that means 0.1, 1 plus 1 0.1, okay, 1.1. okay, comma multiplied by, okay, 0.2. okay, 0.4 divided by 2 is a 0.2, 0.2 plus 2 it is a 2.2. okay, so 0.2 multiplied by 1.1 multiplied by 2.2. okay, this is the required value for k2. So after multiplication you will get the 0.484. okay, 0.484. This one is the value for k2. okay, this one is the value for k2. Similarly, find out the value for k3. okay, so we know that the k3 can be written as k3, which is equal to h under bracket f of x naught plus h by 2 comma y naught plus k2 by 2. okay, y naught plus k2 by 2. This one is the value for k3, guys. okay, yes, so replace all these values here in our formula, you will get the value for k3. okay, yes, h is we have 0.2 multiplied by f of x naught plus h by 2. okay, so you will get the value x naught plus h by 2 as a 1 plus 0.2 divided by 2. okay, 1 plus 0.2 divided by 2, you will get the 1.1. okay, multiplied by y naught plus k2 by 2. okay, so y naught plus k2 by 2, this means y naught, this means y, what we have, y naught 2 plus k2, 0.484 divided by 2. okay, bracket complete. So this one you have to find out the calculation. That means I directly written here. okay, f of xy means x multiplied by y. okay, that means x naught plus h by 2 and y naught plus k2 by 2. This one is the value. okay, so you will get the value for k3 as so k3 at 0.49324. okay, 0.49324. okay, this one is our required value for k3. okay, so I got the value for k3 too. So let's work for the value of k4. So what we want the k4 now. okay, and k4 can be written as h times under bracket, okay, f of x naught plus h, okay, x naught plus h comma y naught plus k3. okay, this one is our required fourth k4 for our Kutta method. okay, yes, replace all these values. okay, so what is the h we have here? So we have the value for h as 0.2 multiplied by, okay, so 0.2 multiplied by f of x naught plus h. x naught means x naught is a 1 and plus h is a 0.2. okay, that means we write 1.2 comma f of 1.2 comma, okay, so f of 1.2 comma, so we have y naught plus k3, so k3 is here, y naught is here, 2 plus 0.49324, that means 2.49324. okay, so these are the value I replaced here, f of x naught plus h and y naught plus k3. okay, that we know that f of x comma y, we write x multiplied by y. So 0.2 under bracket multiply 1.2 multiplied by 2.49324. okay, multiplication of these two one. okay, so we write k4. We are going to write k4 as a 0.5485, 0.5485. okay, we are going to write 0.5485128. This is the value for k4. okay, so we got all the values for k1, k2, k3 and k4. Let's find out the value for y1, guys. okay, so and y1, we know that y1 can be written as y naught plus 1 by 6 k1 plus 2 times k2 plus 2 times k3 okay, 2 times k2 plus 2 times k3 plus k4. Okay, so we have value for y0 is a 2. Okay, k1 it is present here, k2 it is present here, k3 it is present here, k4 it is present here. Replace all these values here in this formula. Use calc, you will get the value for y1. Directly I'm going to write the value for y1 guys here, okay, that we have required here in our solution, okay, which is a 2.84. I found this one value as earlier, so that I'm going to write directly, okay, 2.83, 483, okay, 2.4, let me write again, 2.483, okay, 2.483, 832. This one is our required value for y1. Okay, I hope you all have understood guys. This is the solution for our given example. Okay, it is very easy guys, you just need to remember. Okay, this is the Kutta fourth order formula, that k1, that k2, k3 and k4. Okay, put the value and just like it is a simple calculations, find out the 0.2 multiplied by 2, 1.2 plus 2. These are the very easy calculation guys, and definitely Kutta method that you will get it in your question paper. So make sure that do it properly, focus on it. It is very easy. Okay, I hope you all have understood my today's solution for this example. So if you want, you can note it down this solution, you can pause the video, note it down, use it for your reference, for your preparation. Okay, so if you have any doubt, difficulty, misconception or any concept that you do not understand, okay, so that let me know in my comment section guys. I will come up with this similar video for in our channel. Okay, so here that's it here for our today's lecture guys. I'm expecting that you all have understood my today's solution for this example. Okay, so thank you everyone, thank you for my today's lecture.